Hello! In this video I'm going to talk about the rule modus tollendo ponens. It means a way of putting by taking, and it's a rule that works with disjunctions. So we already have our addition rule that lets us build disjunctions. Now we're going to learn a rule that works like MP or MP or MT, where if you have a disjunction you can get something out of it. So let's look at some examples in English first. Either you give him the ticket or he shoots us. You don't give him the ticket, so he shoots us. That's an example. Let's look at some more. Either I store the nut or I will be hungry. I don't store the nut, so I will be hungry. Or either I store the nut, or another example. Either I store the nut or I will be hungry. I won't be hungry, so I store the nut. These are both valid. If we know this disjunction is true, and we know I don't store, we know that one of the pieces is true. If we learn I don't store the nut, then we know one of the pieces is false, and so it's the other that has to be true. So if I learn the I store the nut piece is false, then I know the I will be hungry piece is true. On the other hand, if I learn that the I won't be hungry piece is true, if I learn I won't be hungry, then I know the I will be hungry piece is false, and therefore the other piece, I store the nut, must be true. So both of these are valid. So if we put this in the logical language, if we have P or Q, if we get not P, we can infer Q. On the other hand, if we get not Q, then we can infer P. So if we have a disjunction and we get the negation of either side, then we can infer the other. Both of these are valid because what we know is the disjunction says one of them has to be true. So if we learn that either is false, then we know that the other is true. And that's true for both the P side and the Q side. If we learn that the P is false, we know the Q is true. If we learn that the Q is false, then we know that the P is true. So in that way, it's simpler than MP or MTP because it works with either side. Whereas MP works with only the antecedent and MT works with only the consequent. This rule works with either side. One rule for both sides of the disjunction. So we have our rules add. If you have box, you can write box or circle. And if you have circle, you can write box or circle. That's a different way of saying it than we said it before, but it's equivalent. Now we have these two new rules. If you have box or circle and you get not box, you can infer circle. If you have box or circle and you get not circle, you can infer box. And we call both of those modus tollendo ponens. It means a way of putting. We're putting a sentence forward by taking away a sentence because we have that negation. But we don't actually care about this old Latin terminology. What we care about is the abbreviation, which we say is MTP. So that's our new rule. We want to look at a few special sort of issues with it, and then we'll look at some in the next video. We'll look at its use in a bunch of derivations. So let's consider this example. Either I store the nut or I will be hungry. I store the nut, so I won't be hungry. What do we think about this? Well, at least if we read the or as inclusive, which we're doing, this is not valid. Why? Well, it could be that I store the nut and yet I still go hungry. Maybe the nut rots, or maybe something else eats the nut, or maybe the nut doesn't rot and nothing else eats it, but it's not enough food to keep me from going hungry. So either I store the nut or I will be hungry. We learned that one side is true. Great. Maybe the other side is true. Maybe the other side is false. We don't know, given that it's an inclusive or, which we're treating it as. So this is invalid. And we think about the version in the logical language, it would look like this. We would have the disjunction and then one of the sides, and we would infer to the negation of the other. And this is not valid. The first premise says that box or circle is true, and the second premise says that box is true. Maybe circle is also true as well, in which case not circle comes out false. So this is not valid, and it's not MTP because it has the negation in the conclusion instead of in the second premise, and it's an invalid inference. So we don't like this one. Good. Now let's look at the second issue. So suppose you had P or not Q, and you also had Q. Could you infer P? Well, you could argue from those two to the conclusion. This is valid, but it's not MTP. This is just like the issue with MT. What we need for MTP is we need the negation of either side. So we need either side plus a negation. So in this case, we have not Q, so we need not Q plus a negation. So what we need is not Q as our second premise. So P or not Q, and then not Q as our second premise, and that gives us P as our conclusion, and that's MTP. Okay, so that's the other wrinkle we need to remember. Just like with MT, you need the negation of the consequent. So here you need the negation of the disjunct, which means the disjunct and then another negation, as we see with this example. Okay, so is this argument, is this a valid form of argument? It is, as I've been saying, right? P or Q, that means at least one of them has to be true. And so if we learn that one of them is false, like let's say we learn that P is false, then we know that Q has to be true. If we learn that not Q is true, then we learned that Q is false, and therefore the other P has to be true as well. So both forms are valid. And so there we are. We have all of our new disjunction rules. And there's a rule sheet assignment where you're going to need to add these. And then that'll be nice. We'll have rules for all of our symbols, and that's good. We're going to be learning a few new rules in our next modules, but they're sort of derivative. They're derived rules. Our rule sheet now is going to be complete, at least in terms of it's having all of our basic rules, all of our primitive rules, rules that aren't justified by other rules. So we have the 4 basic steps of completing a derivation. First, we set up the derivation. We say our show line, maybe we make an assumption, we add any premises, and then we do subderivations if we need to right away. We look to use all of our rules, and so we use our elimination rules, MP, MT, simplification, we take up our biconditionals, now we do MTP if we can, and maybe double negation elimination, definitely. And then our introduction rules, our building rules, if they'll help. So that's ADJ to build conjunctions, CB to build biconditionals, addition to build disjunctions, and DNI to build double negations. And we use those if they'll help. We always want to apply our elimination rules because they're breaking the problem down, giving us simpler claims, which is always useful. We use the introduction rules if it will help, either allowing us to box and cancel directly or to apply an elimination rule. If the derivation gets stuck, then we want to do a subderivation, and we've talked about our different subderivation strategies. And then and we ask, are there any fruitful rule applications to tell if the derivation is stuck or not? And then finally, of course, we will box and cancel. And here we have the derivation setups. So if we're trying to show a letter or we're trying to show a negation, we should assume ID, and we'll probably box and cancel with ID, although we might do direct derivation. If we're trying to show a conditional, we want to assume the antecedent with assume CD, and then show the consequent with show cons. How that's going to go depends upon what the consequent is, but once we get the consequent, we'll box and cancel with CD. If we're trying to show a conjunction, then we will show both of the conjuncts using show conj. How those subderivations will go depends upon what the conjuncts are, but we'll then finally put them together with ADJ and apply direct derivation. Similarly, with a biconditional, you show both of the component conditionals with show con. How that goes, well, you'll want to do that assume CD and then probably do show cons, but who knows, and eventually you finish. What about if you want to show a disjunction? Well, you've actually already done some derivations where you were able to show a disjunction. You built it. You got either box and then built box or circle, or in some others you got circle and then using addition built box or circle. And that can work. It's not a general strategy. We don't have a general strategy yet. You could do assume ID here, and that gives you not box or circle, but that actually right now it's not clear how you would use that. So right now we don't know how to show a disjunction. So that's something that we will be learning in the next module. It doesn't really use any new primitive rules, but there's some strategies and ways of thinking about it that we're going to be learning about in our next module that we don't know yet. So this is our derivation setup so far as we have got. So good luck with your derivations. Let me know if you have any questions.